Hey everybody, how you doing? This is Arthur Morris. I hope all is well out there. Today we're going to look at factoring a quadratic with a leading coefficient of 1. And I'm going to use the AC method on this first one, but it is important to note that you don't have to use the full AC method when your leading coefficient is 1. The AC method is born off of the fact that the general quadratic equation is shown here, ax squared plus bx plus c. So the first step to factoring this using the AC method is to multiply the first coefficient times the last. So that's the AC, and that's where that comes from. So out here to the side, I'm going to multiply 1 times 26, and that gives me 26. So that's my first step here. And I want to find a pair of numbers or factors of 26 that gives me a sum of the middle coefficient, which in this case is negative 15. So I need a pair of numbers that multiplies to give me a product of 26 that also adds up to be negative 15. So I know that my signs have to be the same because that's the only way I can multiply to get a positive number, but I need it to add up to be negative 15. So that tells me that both of my factors need to be negative. So I know that negative 1 times negative 26 is negative 26, but negative 1 plus negative 26 is negative 27. So that pair of numbers does not work. 2 will go into 26 13 times, so negative 2 times negative 13 is positive 26. Negative 2 plus negative 13 is negative 15. So that works out. That's what I needed. So this is the pair of numbers that I'm going to work with. It's negative 2 and negative 13. Now the whole idea of the AC method here is to be able to write this trinomial into 4 terms so we can factor by grouping. So now that we have that negative 2 and negative 13, I'm going to take those two numbers and replace negative 15 with those two numbers. Because negative 2x plus negative 13x is the same thing as negative 15x. So the 1x squared stays like it is. I'm going to rewrite the negative 15x using those two factors that we just came up with. And then the 26 stays like it is, positive 26. So the only thing that I did there was split up the negative 15x into those two factors. Now what that does for us is now it allows us to use the factoring by grouping method to find the factors for this trinomial, So make 2 groups. And since we had a negative 13x, remember that negative needs to travel inside the parentheses with the 13 on that third term. Factor out the GCF from each group. So x squared minus x, I can factor out an x. And if I factor out an x or divide each one of those by x, I'm left with x minus 2 in the parentheses. The second group, now remember, when that third term is negative, then 9 times out of 10 you need to factor out a negative number to make your signs match up in the binomials. So I'm going to factor out a negative 13. So negative divided by negative makes that positive x. Positive divided by negative makes that negative or minus 2. And then the final step is to factor out the common binomial of x minus 2. So I'm going to factor out the x minus 2 here. Write that once since I'm factoring out of the entire polynomial there, and then I have x minus 13 left when I factor out the x minus 2 from each one of those. Okay, so now right here I want you to take a look at this, and I'm going to show you the exact reason we don't have to use the entire AC method to factor this trinomial. So when I made my factors here, found my factors of 26 that added up to be negative 15, I found the negative 2 and the negative 13. If you come down here to your answer, you see in the second place of each binomial, you have those factors, negative 2 and negative 13. So that's factors of 26. goes at the end there. Factors of x squared, which is just 1x and 1x, goes at the, in the first place of each one of those binomials. So split up the x squared, x and x. Find factors of negative or positive 26 that add up to be negative 15, negative 2, and negative 13. And you can skip the entire AC method. So for us regrouping, breaking it up and regrouping and all of that, you can skip all of that if you recognize that you have an understood 1 in front of x squared. All right, so for the next few problems, I won't be using the entire AC method. All right, so here, z squared plus 1z squared plus 1z minus 12. I don't have a common factor all the way across. So I know I have an understood 1 here. So if I come out here, I have 1 times negative 12 equals negative 12. I want to find factors of negative 12 that gives me a sum of the middle coefficient, which is 1 in this case. So factors of negative 12. That gives me a sum of 1, positive 1. So I know if I'm finding factors of negative 12, that tells me one number must be positive, the other factor must be negative, because a positive times a negative is a negative. All right, so let's see here. So now we have, I know 1 will go into 12, so I need to find a pair of numbers that multiplies to be negative 12. That gives me a sum of 1. And before I do that, I'm going to go ahead and make my parentheses here, because I'm not going to use the entire AC method because I haven't understood 1 as my leading coefficient. So that 1z squared, I'm going to break that up here and here. 1z times 1z is 1z squared. Good. So I know 1 will go into 12, 12 times. So we're looking at negative 1 times positive 12. Negative 1 plus 12 is 11. That doesn't work. 2 will go into 12 6 times, so negative 2 times 6. It's negative 12. Negative 2 plus 6 is 4. 3 will go into 12 4 times. So negative 3 and positive 4. The sum of that, negative 3 plus 4, is 1. So those are the two factors I need. So quick and easy, I take those two factors, write them there, and we're done. So again, you don't have to use the full AC method when you have that understood 1 as your leading coefficient. You can find your factors and go directly to your answer. So remember, you can check this by multiplying it back out by using, some of you may use FOIL method or the distributive property. All right, so let's look at this one. So we have 1 times 33 to start off with over here, a times c. I want factors of 33. That gives me a sum of my middle coefficient of 14. So that's saying that I need to find a pair of numbers that multiplies to give me 33, a product of 33 that gives, and also gives me a sum of 14. So I know 33 divided by 1 is 33. If I add those up, that gives me 34. And again, I know my signs of my factors have to be the same, either both positive or both negative, because this product is positive. Now my sum is positive as well, so that tells me that both of my factors need to be positive. 2 won't go into 33, but 3 will. 3 will go into 33, or 33 divided by 3 is 11. 3 plus 11 is 14. There we go. That's what I needed. So again, make my two sets of parentheses. I split the y squared up into the first place. I put the factors in the second places, so positive 3 and positive 11. And those can go in any order. It could be positive 11, y plus 11 times y plus 3. Okay, so let's see here. We have two variables, same process. Look for a GCF all the way across. I don't have a GCF all the way across. So I have 1 times 39. It's 39. I want to find factors of 39. That gives me a sum of 16. Okay, so we know 1 and 39 won't work. We know 2 won't go into 39, but 3 will go into 39. 39 divided by 3 is 13. If I add those up, that gives me 16. So those are the factors that I need. Now the difference is here is that I have an x squared here and a y squared here. So when we set up our parentheses, we need to put an x and we need to put a y at the end there. So an x and then a y. Now you see I left a little space after the plus because my two numbers are still, two coefficients or factors here that I found are still going at the end with the y. So 3y and 13y. So x plus 3y times x plus 13y. Again, we put the y at the end there because we had y squared, so we have to split up that y in the last place there. The x squared, we split that up to go x times x, y squared, y times y. So if you notice, a quick check, if I do x times x, that's x squared. If I multiply 3y times 13y, that's 39y squared. So you have to have the factors of the first term there in the first place of each binomial, and then the factors of the last term in the second place of each binomial. Okay, so here 1 times 36, and you may want to pause it and try it yourself. So we want factors of 36. It gives us a sum of negative 15. So since I'm getting factors of a positive number, I know that the two factors must be the same as each other. I want the sum to be negative, so that means I need to have two negative factors because a negative times a negative makes positive 36, but a negative plus a negative will give me that negative 15. And you can go through your factors, 1 and 36, 2 and 18, 3 and 12, and that sounds good. So negative 3 and negative 12 multiplies to be positive 36 and adds up to be negative 15. So x, and remember you have that y squared there, so minus 3y. Split up that x squared again, so x minus 12y. So again, we use the y at the end because we have y squared in that last term. Okay. All right, this one says factoring out a constant before factoring a quadratic. So you may want to pause and write that down. All right, so again, I always say look for a common factor all the way across. In this case, we see that 4 will go into 4x squared, 4 will go into 40, and 4 will go into 64. So the first thing I need to do is factor out my common factor of 4. And then I have remaining, after I divide each one of those by 4, x squared plus 10x plus 16 in the parentheses. Okay. So just because I factor out a common factor doesn't mean that I'm complete. I have this trinomial in here that I need to see if I can factor it down or break it down even more using that modified AC method. So we have an understood 1x squared plus 10x plus 16. So now out to the side, I'm going to start off by multiplying 1 times 16 to see if I can factor the trinomial on the inside even more. So I want factors of 16 that gives me a sum of 10. So what you're thinking is there anything I can multiply to get 16 that also adds up to be 10? So we know both factors have to be the same as each other because I have positive product here and my sum is positive 10, so we know that they both have to be positive. So 1 and 16, 17, 16 divided by 2 is 8, 2 plus 8 is 10. Ding, 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 that's what I needed. So now keeping the 4 here, I'm going to make 2 sets of parentheses and factor that trinomial. So I have x squared, so that means I have x times x at the beginning here, Then I had 16, so I needed factors of 16 in the second place. And that's going to be the 2 and the 8 to make it work, because 2 times 8 is 16, and 2 plus 8 is the middle of 10. And then that is completely factored. Okay, let's look at another one. All right, so here we have 5x squared minus 45x plus 90. And I'm going to, I say I can factor out of 5. So let's see here, we have 5. So divide each one of these by 5. Which leaves us with x squared. Let's move this down just a little bit. Leaves us with x squared minus 9x plus 18. All right, so now I need to see if I can factor out the trinomial, and I'm going to do mental work this time. I have that understood x squared, so I'm going to leave my 5 like it is. So I'm trying to figure out, is there anything that I can multiply that gives me, multiplies to give me positive 18, which means either 2 negatives or 2 positives, and adds up to be negative 9. So think about that just for a second. All right, so hopefully you came up with negative 3 times negative 6 is positive 18, and negative 3 plus negative 6 is negative 9. Alrighty, I hope you found it to be helpful. The next couple problems I had were pretty much the same, so I hope you found that to be helpful. All right, thank you.